Make sure that you take the time to read the information which is mentioned right here. So take your time to check out this information, and keep in mind that we just noticed that we can call another name for G would be F inverse with that special notation. So when we found that fog of X and gof of X were both X, instead of G I can write F inverse, so I would have F composed with F inverse of X is equal to, and instead of G put F inverse composed with F of X, and that's equal to X. So everywhere you see a G, you are free to write F inverse. So notice that F and G, what did they do? They swapped X's and Y's. Do you remember, any point you pick, you can swap the X's and the Y's. So F and G swap X's and Y's. You can see that F and F inverse swap X's and Y's. What else do they swap? Since the domain is related to X and the range is related to Y, if F and F inverse swap X's and Y's, they surely swap domain and ranges as well. So all of that information is really powerful if you think about it, and it's all listed there in the following over here in the following paragraph that I have. This document right here, all of this is mentioned right here. So make sure you read that carefully. Now what I would like to do with you is something else. So what I would like to do next with you is the following. I want to show you how to find really the inverse of a function. And keep in mind that if you have the function f of x and its inverse x over here, x over 4, when f of x is 4x, not only do they swap domain, ranges, they swap what? X's and y's, okay? So that's very important. Keep that in mind, because at some point you will see that I'm swapping x's and y's, okay? So now let's take a look at the steps they have for finding the inverse of a function. And those steps are listed right here. It's called finding the inverse of a function, the switch and solve strategy. The equation for the inverse of a function f can be found as follows. Replace f of x by y in the equation for f of x. Interchange x and y. Solve for y. If this equation does not define y as a function of x, the function f does not have an inverse function and this procedure ends. If this equation does define y as a function of f, then the function f has an inverse function. And this inverse function deserves the notation f inverse, and we replace y by f inverse in step 3. And we can check by composing f and f inverse one way and the other way around, and we should get x for both of those compositions. So we're going to take a look at an example of how to apply this rule. So let's go ahead and do the following. Let's say that you wanted to find the inverse function of the given function f of x is equal to 4x. So first thing, and they should say if it exists. Notice they are calling it the inverse function, and if it exists you can call it f inverse. Now let's go ahead and see how we do our steps. So first thing we do, instead of f of x, we're going to write for f of x, we're going to call that red y. Now red y goes with red x, so let me put a matching x color here in red. Okay. Now those x's and y's are for the function f. When they tell you to find the inverse function of f of x, what they're asking you to find is they would like you to find f inverse of x. And that's of course if it exists. If it exists, okay, I will call it the following. F inverse of x, I'll call it blue y. You can only go from blue y to its other name f inverse of x if f inverse is a function. So let's go ahead and proceed further. Let's remember that x and y are swapped when you go from the function f to the function f inverse. So let's remember right here, you do have some swapping around of x's and y's for f and f inverse. So that's what I'm going to do right now. So what I have is I have red x, red y for f. I'm going to, wherever I have a red y, put a blue x, and wherever I have a red x, I put a blue y, and everything else stays the same. So make sure I did a good job changing a red y into a blue x and a red x into a blue y, and you do that wherever it occurs. In this case, just one place for both of those. So I'm going to record what blue x and blue y are for. Those are not for f anymore since I did some swapping. They are for our f inverse of x, again, if it exists. Now, in order to find f inverse of x, we need to solve for blue y. Notice blue y is here, so let me go ahead and do the following. Let me just go ahead and divide both sides by 4. So let me write that same equation I had. If I really want blue y, I need to divide both sides by 4. So I'll get from that blue y is equal to x over 4, and I can swap both sides eventually, and I usually swap both sides right at this stage, you know, just to have blue y that I'm solving for on the left, but I didn't do that sooner. So what I'm going to do next is the following. I'm going to finish up over here. Let me just get a little bit more room here. Okay, just wait a second. Okay, so I am now finishing up by swapping the two sides. So blue y is blue x divided by 4. And let's remember that we need to think at this stage according to them, solve for blue y. And if this equation defines a function, we can call blue y f inverse of x. So if you were to graph y is equal to x over 4, you would get that line that we drew before, and this line passes the vertical line test. So this graph is really the graph of a function. So blue y is really defining a function, and it's allowing us to call blue y f inverse of x. So f inverse of x does exist, and it's like replacing blue y by f inverse of x, and we get that equation that f inverse of x is x divided by 4. So in order again to go from blue y to f inverse of x, we need to check that this equation defines a function, that it passes the vertical line test before we finalize step 4 right here. So think about this.